My brother-in-law is in hospice, and my wife's a nurse, so we're staying with him. So as he transitions, hey, Kendrick. Oh, you did? Oh, no. Glad you got it back. Good to see you guys. All right. Well, we are going to go over stuff that we talked about yesterday, Kylie. So this will be good for you. Let me get this going here. Where are you? Quizzes. Okay. We're going to start this energy um, thing here. So let's do that. Okay. So we're going to do instructor paste on this assignment here. So we're going to talk about the energy skate park. Yesterday we were talking about kinetic and potential energy. So this is what we're going to do today. Let's see who, Thomas, good to see you, Thomas. And John, good to see you. Grace as well. And Adriana. Okay, if you guys would jump in there, we're going to go over potential energy and kinetic energy. So if you remember, potential energy. Okay, see if I can draw on this. So potential energy. So in the half pipe here, potential energy is up here, right? So you're getting ready. The potential energy is the highest here because it is the highest above, and then potential energy is down here is zero, right? Right? But when we start going, so we go from potential energy from high to low. And then if we talk about kinetic energy, so kinetic energy, so this is our potential energy, let's say is high, and then this is zero. So this is going to be our high point because it's so high and low. And then we're having the kinetic energy. Now the kinetic energy, let's change the color here. Kinetic energy, right, in blue is going to be low, or zero. I should say this is zero here. Let's make this potential energy, the kinetic energy zero. And here we have potential energy is really high. So as we go back and forth between the two. So potential energy goes from high to low, and kinetic energy goes from low to high. So low to high, or nothing to high. All right. So that's what we're doing today, just to kind of go over this. So let's start. Thanks, Rachel, Chloe, and all for getting in there. So let me hide my face for a minute. Okay. So observe the model. When does the skater have the most potential energy? And remember, we said right up here, really at the top of the ramp, right? The top of the ramp, potential energy. Potential energy is gravitational potential energy. Well, all right. So we got everybody in there. Good job. Next question. You guys are answering those questions quickly. So where is the potential energy the least? Remember, right here at the bottom of the ramp is where it's the least, okay? Because we have height. We have height here, and we have no height, none right here. No height down at the bottom. All right. How'd we do? All right. Top of the ramp is kinetic energy. Bottom of the ramp is no potential energy. Kinetic energy has the most at the bottom. Right. So remember, kinetic energy is motion. Where does kinetic energy have the most? And that is at the bottom, right? The bottom of the ramp is where kinetic energy, you can see right here, when you take a look at this, kinetic energy is over here, and it's the highest. If we look at the values of them, it's highest at the bottom because it's speeding up, right? Speeding up. All right. Oh, that's okay, Kylie. All right, so what does the skater have the least kinetic energy? And remember, that's at the top of the ramp because we're not moving very fast, or we're moving zero. Top of the ramp, we're not moving at all. That's where most of the potential energy is. So the top of the ramp is where there's no kinetic energy or very little. Two more questions. All right, so the skater's potential energy. Skater goes from loses potential energy as it travels down the ramp, right? Because the height changes, right? It loses. So potential energy is high here and low there. It's the opposite for kinetic energy. Kinetic energy is low and then goes to high, right? They switch places. So as we lose potential energy, we get more kinetic energy. Well, no, two more questions. I thought we had one more question here. All right, so what about kinetic energy? Kinetic energy gains as we travel down the ramp, right? Because we're speeding up, right? Goes from low to high for kinetic energy. And you can see that from the graph over here. If you're watching the graph, you can see that. Next question. Last question. All right, so let's see what you got here. What statement accurately describes potential and kinetic energy in a system? Right? So as a skater gains kinetic energy, they lose potential energy, right? Because if we're gaining it, they lose it, right? We gain kinetic energy as we go down, but we lose potential energy as we go down. Hey, we got everybody in there. Excellent. Thanks so much. All right. Who do we got? Kendrick third, Chloe second, Rachel first. Okay, so okay, let me go put this in here. All right, so I was wanting to do this over the week, but these are the people that uh, were invited. Everybody was invited to along, and these are the people that um, got into the drawing for along. Again, I'm trying to figure out a way to communicate with you better. All right. And we're thinking that maybe that if I used a different platform, it would work better. Right. So I have a $5 gift certificate to, Wendy's or Burger King or McDonald's for one of these people. And I'm going to pick a winner here, and I'm going to um, send them an invite message on along. So we'll see how that goes. So you have to respond to it. If you want to join along, I will send out Rachel. Okay, Rachel, I'm going to send you on a long message, and you send me back what gift card you would like. Okay, all right. Thanks so much for playing. We'll do this again. I'm going to try to get people over um, the next couple weeks to see if we get some more. I want to do some more communication, especially because of testing. Okay, I want to do some testing, and again, I want to see if this works. Because I looked at somebody's emails, they were showing me their grade, and they had 145 unread emails. So, and that is pretty typical. I usually leave you messages in on email for win days, and I get anybody see my dog talking to you guys? Anybody see that when you looked at your email? Anybody see Lizard talking to you last couple weeks in my email? Anybody saw that? Oh, you saw it, Rachel. Okay. All right. So, okay, John saw it. So there, so I try to make it so that you look, all right? So again, I'm trying to pay you guys to come and join along so I can communicate with you. So I have my dog talking to you, and I have a lizard talking to you. I've even had a smiley face talking to you guys. So trying to give you information just to make things a little bit more, I don't know, comical maybe, a little bit more friendly. So I will send Rachel out a note, and she can tell me what if she wants Burger King. She might not want any of those, but um, that's the ones I can have available. So we'll have another one over testing to see if I get more people to communicate with me. We'll have another drawing. All right, so what we're doing today, let me go close this out. All right, so I want to ask you about this. Oops, I'm going to publish a poll. Let's start a poll, A, B, C, or D. So we're going to be talking about calculating potential and kinetic energy, right? So if you know nothing about kinetic or potential energy, then that's okay. You will put down A. And we'll have this vote at the end of the hour to see if you move from no idea to some idea. All right, so we're going to work that in that direction. And thank you guys for getting in there. Not many people putting C, one person putting D. I appreciate you guys so much. Hey, Blake, I did not say hello to you. Madeline, good morning. Didn't say hello to you either. Hey, DeAndre, I didn't say hello to you, or Journey. Thank you, Journey. And who else? Did I get anybody else? Maybe I said hello to John. I'm not sure. But you guys, thank you guys for all you do to participate. It's a lonely business if I don't get, if you guys weren't here, right? I might as well just record myself and that's all. Okay, so more people said zero or A, no idea, and less people said the other. Okay, so let's talk a little bit about what we were doing this week. Okay, so first of all, we were talking about skater going down a half pipe, and we were looking at mechanical energy. The total mechanical energy is a combination of kinetic and potential. Potential because of gravity pulling you down. You wouldn't be able to skate at all if you didn't have gravity. Wouldn't be holding you to the ground. And then the speed that we create is because it transforms from potential energy to kinetic energy. So there are other ways to transform energy on your road trip. Okay, you might use gas, you might use electric. I have an electric car, and I am really afraid to go very far with my electric car because it only travels up to 200 miles, and there's not many service stations for plugging into electric, right? So it's pretty tough for me. And who else did we get in here? We got somebody new in here. Okay. Hey, Dylan, good to see you. So we're transferring either the chemical energy of the gasoline, right, to motion. So we transform the energy. So that's conservation of energy says energy cannot be created or destroyed, but it can be transferred. Okay. Matter cannot be created or destroyed, right? But energy is a little bit different in that it can be transferred from one thing to another. So energy transformations, the chemical energy in the gasoline creates the engine to, starts the engine, and then you get to have some motion. So you have some physical kinetic energy there, right? Radiant energy from the sun produces chemical energy in the plants, and that's radiant to chemical. So that's stored chemical energy. And we get to eat whatever is produced for us by the sun. Everything's produced for us by the sun as far as where we eat. So chemical energy is stored chemical energy to motion. So we also use that as electrical impulses in our brain. And then chemical potential, it's kind of, they also call it chemical potential energy because if you're looking at a battery, it's got the potential to create electricity, and this creates the sound in the devices that you buy, right? And then finally, again, electrical appliances, right? So we have, and again, out west, they use hydroelectric dams to create electricity, and they're using gravity of falling water to produce that. So electricity to thermal energy, right? So, and most in the next probably 20 years, you will not probably see very many gas stoves anymore because we're going to try and move away from things that pollute the earth and try not to use. So everything will be electric. So your houses will be electric, hot water heaters will be electric. I know most of us have not electric. We have gas stoves and we have gas appliances like hot water heaters and heaters. Okay, so in summary, the law of conservation of energy says energy cannot be created or destroyed, can be transferred between object or transformed from one energy form to another. It's a closed system, and remember we talked about a closed system where energy can leak out, but the matter stays in. Okay, it's like has a cap on it. So every time you listen, cook, or use your computer, or even just run, you're transforming energy all the time. So let's take a look at this question here. So which of the following best describes how energy is transformed from one form to another? Energy is created during the process. Energy is destroyed during the process. Energy is converted from one form to another, or energy remains constant through the process. Thank you guys for getting in there. I appreciate it. So A, B, C, or D for me. Thanks so much. Madeline, Kylie, thank you guys. Thomas, Blake, thank you. Good. Thank you. Good morning to you, Blake. So, and if you have written this down, we have 10 out of 15, 2/3 of the class. That's really great. So we have most of you saying letter C, right? Letter C is what we're looking at here. So let me get that out of the way. So energy is converted from one form to another, right? There we go. Letter C. All right, so let's other conservation law here. What is the law of conservation of energy? Energy can be destroyed, energy can be created, energy cannot be created or destroyed, only transformed, or energy remains the same in all forms. And you guys are on the ball there for sure. On the ball. We got 3 people got it out there. Thank you much, Chloe, Dylan, and John. Thank you much. Got 5 out of 15. I had 11 out of 15 a minute ago. So 7 out of 15, right? We'll see how many people, we're going to do some calculations today, and that might cause some people some consternation or concern. All right, so we got 9. And most of you guys said energy cannot be created or destroyed, right? And it only can be transformed. And that's what, and you'll see this in your notes as well. Okay, so which of these is an example of potential energy transformed into kinetic energy? Is it the roller coaster moving uphill? Is it a book sitting on the shelf? Car parked in the driveway? It might have a slant. Okay, put it in gear, or water flowing in the river. So potential energy is gravitational potential energy in a lot of cases transformed into movement. So which of these are moving, right? Which of these are moving in this particular case, right? So what we're doing for the roller coaster, unfortunately, we're creating more potential energy, right? This is one we're creating potential energy. So potential energy, so we're moving it to create potential energy. So what we're looking for is the water flowing. So water flows from high ground to low ground, right? So we're using that potential energy created from the height to get that kinetic energy. So this is letter D in this particular case. Letter D is what we're looking for here. Let's get this, letter D. Okay, so here we're going to do some calculations. Okay, so follow along with me. And again, this is our goal today, trying to understand kinetic and potential energy calculations. And they're straightforward, only multiplication. All right, so I'm going to give you, this is kinetic energy KE8. All right, so let's work on this one together. You can get your response anytime you want. I will show you how this works. I'm going to take my face off here, and I'm going to open. Okay, so what I'm going to do is walk you through it, right? Kinetic energy is this thing where it says 0.5 times the mass times the velocity. So 0.5 is in the formula. but the mass 756 goes in this part here. And if you know what velocity squared means, it's velocity to the second power, but we're going to show you that just means 15 times 15 if you can't find that. So let me go over to my calculator here. All right, I'll clear this out. All right, so 756. So 0.5 times 756 times, okay, wait a minute, I forgot what it was I was looking at here. 15 times 15. I completely forgot it was 15 times 15. All right, let me get back over there. 15 times 15 times 15 times 15. Now you could have just used the squared function here, but I don't see it offhand here. So what do you get as far as the answer here? What do you get as far as the answer? 0.5 times 756 times 15 times 15, and that'll be in joules. Probably I'm not going to get 15 or 10 people like I did before, but maybe we'll get half. Maybe we'll get like 7 people on this particular one. I don't know what it is about math problems. People just like, I'm not going to do that. I don't want to do that. You know, but again, straightforward multiplication using the formula. And that is one of the guidelines or one of the things that we try to get people to understand how to do, because using a formula in your state test is pretty common, right? Pretty common. All right, so what do we got here? All right, so let's do this. 0.5 times 756. All right, so we should have had 85,050. 0.5 times 756 times 15 times 15. All right, maybe somebody put 15 plus 15. Did I do that right? 756 times 3. Yeah, I think so. Okay, so we got a few people that got that one right. All right, so 756 times 0.5 times 15 times 15. All right. So let's try one more. So this one was 85,050, right? So let's try the next one here. Let's try this one again. This is going to start a poll, and this is going to be kinetic energy 9. All right, so let's start this one. Type this in here. So we're going to find the kinetic energy of 29 kilograms, right? 29 kilograms, 29. So 0.5, oops, got my pen, it's not working. There you go, 29 kilograms. And the velocity, so that's the mass, so 0.5 times the mass, and 4 times 4. 29, let me clear this out, 0.5 times 29 times 4. Oops, I'm not showing you this, guys. Let me show this to you guys. All right, let me get this a little bit bigger, maybe. That'll be easier to see. See if I can make that. There we go. There we go. 29 times 4. 0.5 times 29. So 16 times 29, or it's actually like 16 times 15 if we were looking at that. So start the poll. What do you get? What did you get for this response? 0.5 times 29 times 4 times 4 in joules, right? All right, we got 3 people. Got it. Got it's something in there. Good job, ladies and gentlemen. 5 out of 15. So 6 out of 15. Can anybody else get in there? So like I said, it's pretty straightforward if you have the formula, right? And the problems on the test will be straightforward like this. There's one tough problem in a assignment 2 we'll go over on Friday. So 7 people said 232. Very good. Very good. Okay, so stop there. We had, all right, so one person said, oh, I think another person had the original problem there, 29 times 4 times 4. Okay, so let's do a potential energy problem. All right, start a poll on this one. This is potential energy 10. So your assignment today is to do 4 problems in the exit quiz that are just exactly like this, right? All right, so let's start a poll here. All right, so this says potential energy is the mass times the gravitational constant, 9.8, times the height. So let's do this. Okay, so we're going to go, let me get this in here. Okay, so this is going to be 2 for our kilograms, right? And this is going to be 9.8 times 14. So the difference between the speed and this concerns height and 9.8. So let me let's get this one going here. So it's 2, so it's not 1.1 or 0.5 times anything. We just have to remember that it's 9.8 and then we multiply by 14. So this one doesn't, you don't have to do times like the one was squared, right? So let's see what we got here. So what do you get? 2 times 9.8 times 14. So what do you get? 2 times 9.8 times 14. All right. So we have some numbers a little bit different than before. Okay. So 2 times 9.8 times 14. We got 6 out of 15, almost half of the class. And we got 274.4. Okay. All right. So let's, one last problem, 274.4. Let me put that in 200. Oops, can't do that. 274.4. All right, last problem here and we'll be done. Okay, so this one is start a poll. This is PE11. Okay, so we're going to do this one, start the poll. We have 45 kilograms is our mass. And it actually doesn't matter which way you put them in here because they'll all come out when you're multiplying straight across. Doesn't matter if you put the 10 in here, but this is, kilograms is your mass. 9.8 is something you're going to have to remember. Okay, so we're going to take 45 times 9.8 times 10, right? Oops, I got a plus in here. Why do I have a plus in there? Backspace it. Okay. All righty. There we go. Let's do that together. So 45 times 9.8 times 10. All right, looks like you got quite a few. Publish the poll, and we've got 4,410. Great job, ladies and gentlemen. All right, so let me ask this question, okay? How are we, oops, this is an ABCD question. ABCD, this is our final results here for our, how you think you're doing. Did you go from A to B? Did you go from B to C? All right. Yeah, some of you guys moved from A, no idea, to B, no sum, right? So the notes are available there for you, ladies and gentlemen, so that they are in the notes. So you should have those. Like I said, there's only one problem, a couple problems in worksheet number 2, week 10, worksheet number 2, that combines both information from yesterday and today. And it's a little more challenging. We'll go over that on Friday. Okay. All right. So Today, what you're going to try and do, okay, is a couple things. You get this going for you. All right. Okay, so we have the notes in here, the 4.3 calculating. We have the 4.2, and you'll see that in the module. All right, so that's all in there. All right, and you also will find that here is, okay, 4.3 kinetic and energy exit quiz. Okay, so I'm going to give you guys this. All right, let me clear the polls here. All right, so this is, this is supposed to say 4.3. Let me edit that. Nope, that's not it. Module. Okay, so this one is 4.3. Where are you, Mr. Okay, here it is. 4.3, calculating potential and kinetic energy. There we go. All right, so this is the exit quiz. There are 4 problems. Fill in the blanks. 4.3 exit. 2 problems on kinetic and 2 problems on kinetic potential. All right, here is the link for that. All right, we haven't done these Google assignments in a while, so remember, you click on the blue link there, and then you get your problems, right? Fill in the blanks there, 4 problems. All right, I have to grade those by hand. If you did not finish 4.2, all right, which is here, the PE exit quiz, where we're using the ramp, okay, using what we just went over this morning. All right, so this is the exit quiz for that. Remember, these are bonus points and they are due by Friday. So they will not be opened up again after Friday, right? And then the last one in the modules was 4.1. So if you haven't done those and you're just new to us this week, okay, exit quiz. This one was on energy systems. Remember, open, closed, and isolated energy systems. If you don't know what we're talking about there, make sure that you go over the notes before you do it. All right, so I am going to pause the assignment there.